Hello student, welcome to our first lesson, and this is electrical conductivity of solids. Here we have a circuit, and here we have the battery, we have the flow of the current, and then we have the flow of electrons. Here we have a switch, we have the crocodile clips, these are the crocodile clips. Then here we have solid to be tested, it will be connected here. Then we have a bulb to show whether the current is flowing or not flowing. In order to determine whether a substance will conduct an electric current or not, electric apparatus are set up as shown in the figure 5.1 above to make the circuit electrical circuit. Substances or solids to be tested are aluminum, magnesium, zinc, sulfur, sodium chloride, lead bromide, lead iodide, graphite, wood, and sugar to be tested. They are connected between the two crocodile clips. So all these substances or these solids, because we are testing the electrical conductivity of solids, will be connected here. A bulb is used to test whether a current is flowing when the switch is closed. So therefore, when the switch is closed, it means the circuit is complete. The bulb lights up if the substance used allows the electric current to pass through. If the electric current pass through the solid, then the bulb will light up. If it doesn't, then it means the substance used here, it does not allow the current to pass through. Therefore, substances which allow electric current to pass through are called conductors, while those that do not allow current to pass through are known as non-conductors. Only aluminum in the experiment, zinc, magnesium, and graphite are found to conduct electrical current, while solids like sulfur, sodium chloride, lead bromide, and lead iodide, wood, and sugar do not allow electrical current to pass through, meaning they are non-conductors, while aluminum, zinc, magnesium, and graphite are conductors. Aluminum, zinc, and magnesium are metals. Metals conduct electricity, which because they have free delocalized electrons. So if a question asks you why solids like aluminum, zinc, magnesium conduct electric current, it is because they contain free delocalized electrons which moves freely from one point to another within the metallic structure. Graphite is a nonmetal. It's not a metal. It's a nonmetal, but it conducts electric current. Why? Because graphite is made up of carbon atoms which are bounded in a way that result structure that have some delocalized electrons. So like the metals, graphite, which is a non-metal, also contain delocalized electrons which are responsible for electrical conductivity. The battery in the circuit provides the necessary driving force which makes electrons to flow from one direction through the circuit. So you will see the direction of the flow of the electric of the current and the electrons. Note, the current flows in opposite direction from to flow as indicated in figure 5.2. So the current and the electrons flows in opposite direction as indicated in this slide. So here we have the circuit. Then when you close the circuit, then you'll find that the current will flow in this direction, while the electrons will be flowing in this direction. So as demonstrated, so that is a flow of electric current it will flow in that direction, move that way, while the flow of electrons is that way. So the electric, when the electrons flow this way, then the current flows in the opposite direction. It is good to note that. Now here there is electric conductivity assignment on solids. We have question 1, we have the diagram, study and understand, then answer it correctly. You'll find the answers in the notes section. Then we have 5 questions, and then make sure you understand, explain well, check on the spelling, and also make sure that you do it well. Thank you, and we wish you the best.